Okay, so let's look at what page is this? Page 3. So this is the calculator section. In the first part, it says f plus g of 2. And all that means is f of 2 plus g of 2. So f of 2 means what's the value of the function, the graph of f, when x equals 2. So here's x equals 2, and if you trace it down, you can see that the value of f of 2 is negative 2. So f of 2 is negative 2 here. G of 2, if I go up and across, I see that g of 2 equals 5. So this total here is 3. So let me get that out of the way. F times g of 1 means f of 1 times g of 1. So f of 1, if we look that up, f of 1 is negative 1 here. And g of 1 is 4. So it's negative 1 times 4, which is negative 4. G over f of 0. Okay, so that means g of 0 over f of 0. G of 0 ends up being 3. F of 0 ends up being 0. Now, the problem there is that you can't divide by 0 ever. So this is undefined. And then the last one, a lot of people thought this was multiplication just like in B, but it's not. That little circle means composition. So this is really G of H of 4. That's the way to interpret that. And H I gave you right here. So H of 4 is root 16 minus 4 squared, which is root 0, which is 0. So this is really G of 0. And G of 0, which we figured out in part C, was 3. In 6, it says use the graphs from number 5, figure out if f is 1 to 1. So f is 1 to 1 if f is a function and f inverse is a function. That would make f 1 to 1. Now the way to test these things, f is a function if it passes the vertical line test, and f inverse is a function if f, the original, passes the horizontal line test. Okay, so f needs to pass this, and regular f, not the inverse, needs to pass the horizontal line test. So you already know f is a function because it says so right here. So you don't need the vertical line test, but if you did it anyway, well, it passes the vertical line test, right? Only hits once or not at all. Horizontal line test, well, it passes up here, but then once you get to the x-axis, it fails the vertical line test for lots of values there. So f fails the horizontal line test, so f inverse is not a function. So f is not 1 to 1. Another way of thinking about 1 to 1, and I accepted these answers as well, is, let me get rid of this, is that every x should give you one y, and every y should give you one x, and only one in each case. And if you look right here, this is the equivalent of the horizontal line test. This y value of negative 1, for example, it gives you two different x's. So that means y goes to two things. That's 1 to 2, not 1 to 1. So this one is not going to be a 1 to 1 function. Okay. In number 7, I redid the graph down here so we can see it. We need to graph f of negative 2x minus 1. So f is, there are 3 critical points on f. 0, 0, negative 2, 2, and 6, 6. So those are on the graph of f. So I'm just going to write down here f. The points that it has is, in fact, I'll write f of x. So the points that f of x goes through are 0, 0, negative 2, 2, and 6, 6. Well, somehow I have to transform it into negative 2x minus 1. F of negative 2x minus 1. So let's do f of 2x first and see what happens. So if I do f of 2x, that is a horizontal shrink by a factor of a half. And what that does to my points and to my graph is it shrinks it in. Everything gets squished towards 0, 0. And so like if I used to have x equals 4, well now it's at x equals 2 because it got shrunk. So 0, 0 doesn't change, but negative 2, 2 does. Sorry, that's 2, negative 2. Let me fix that. 2, negative 2. Right? Because 2, negative 2 is going to get shrunk in now. So that's going to be 1, negative 2. Right? Because the x's get cut in half. And then 6, 6 turns into 3, 6. Now, let's make it a negative 2x. So that's the same thing as flipping over the y-axis, right? F turns into 2 times negative x. The x switches out for a negative x now. Okay, so what that does is this is still 0, 0. The x switches sign, though, because I flipped it over the y-axis. So this becomes negative 1, negative 2. And this becomes negative 3, positive 6. And then the last step I need is to subtract 1 from the y's. So that's a shift down 1 unit. So that'll give me the f of negative 2x all minus 1. So now I just take 1 away from the y's, 0, negative 1, negative 1, negative 3, and negative 3, 5. You don't have to do those translations in that order. Those, not just translations, transformations in that order. You could have done them in any order, really. You just got to be careful about how it affects the points. So, you know, let's say I wanted to shift down first, right? So I take my original points right here. I take the original points, and if I shift down first, so then that would be, let's see, a shift down would make it f of x minus 1. So then I would get 0, negative 1, I'd get 2, negative 3, and I'd get 6, 5. Then let's say that I decided to flip it, right? So that's going to flip all my x values. 0, negative 1 stays the same because 0 doesn't switch signs at all. Negative 2, negative 3 now happens, and instead of 6, 5, it's negative 6, 5. And then I can, I need the horizontal shrink. So I'm going to do, I'm going to replace the x with a 2x, right? That's the horizontal shrink by a half. So then this is going to turn into now 0, negative 1, negative 1, negative 3, and negative 3, 5. Same points that I had before, I just did it in a different order. So anyway, when you plot those points, here's 0, negative 1, here's negative 1, negative 3, and here is 1, 2, 3, up to 5 right there, 3, negative 5, and it looks like this.